All right, so in this assignment, we are going to be creating this cylinder. The cylinder has a couple of cutouts. One of them is positioned perpendicular to this vertical axis. The other one is at an angle from the axis. So a couple of new cutouts, new things that we haven't done before. We've got some reference geometry as well. So this is what we are going to be making today. So let's get started. You open up NX. We're going to go to a new file. Make sure that we are making a model that is in inches, and we are naming this correctly, and we are saving it to a location that we can access later. So before we jump in, we're going to talk about this little datum CSys that we have been seeing. So this is a datum coordinate system, and it's one of the three different coordinate systems that we're going to talk about. So a datum coordinate system is simply made up of 3 planes, 3 axes, and a point, that origin point right there. And we can access any of the planes or the axes or that origin point to help us create sketches, define boundaries. We can use them for anything that we need. We also have a absolute coordinate system, and the absolute coordinate system cannot be changed at all. When we create a model, when we open up a model, that absolute coordinate system is embedded into that model. We cannot change it. We can change this datum coordinate system. In fact, we can add as many as we want. We do that by coming up here to the construction tab, and where it says datum plane, if we hit that drop down menu, we can create a datum plane, a datum axis, or a whole nother datum coordinate system. And we can choose where this coordinate system is at. We can angle it. We can do whatever we need to. But we're referencing it, or we're positioning it in reference to, right now, the WCS. The WCS is our work coordinate system. The work coordinate system is the coordinate system that we are actively in. So that would be this datum CSys right here. We are in this work coordinate system. So when we say it is 7.1 inches in the positive y direction, we are saying the positive y direction in respect to this datum CSys. But I can change that. So instead of the WCS, I can change it to the absolute. Now, the absolute coordinate system, remember, cannot be changed. I can change my work coordinate system. I can change these datum CSYS, but the absolute coordinate system is always going to be the same. But when we create these datum CSYS, I can hit OK, and it's going to create that. And if I wanted to create a sketch that was along one of these planes, I could do that now. So this is helpful when we have some geometry that is kind of hard to draw on just the datum CSYS that we are given. We can create one. We don't have to create a whole datum. We can just create a plane or just create an axis if we need to. And that's what we are going to be doing when we create our these cutouts. We're going to be creating planes and then sketching on those planes, and then we are going to use that 2D boundary to subtract the right material. So let's get started. We are going to draw this cylinder, and then we have a 3-inch cylinder extruded to 2 inches, and we have a 1.5-inch hole going through the center. So let's get started. Let's create a sketch. We can sketch on the top plane. Start by making a circle. I want it to be at the origin. This is going to be is going to be 3 inches in diameter. Sketch is fully defined, finish. And we want to extrude this. When we extrude this though, I really want the origin here to be in the center of the cylinder. If we go back and look at the drawing, you kind of see that this, we have a section view that's going through the center. It just looks like the best way to make this is to have that origin at that center location. So that's what we are going to do. So I don't want to extrude in just one direction. I want to keep this origin point in the center of our model. So rather than going to a value, I want a symmetric value. So the symmetric value is going to, and I just changed this. It used to be the distance that you put in here was only from the sketch to the edge. So if we wanted a 2-inch overall distance, we would put in a distance of 1. They've changed it though. So the distance here is the overall distance. It's from this face to this face. So we do have a 2-inch distance here. We use that symmetric value. We can hit OK. And now you can see our sketch that we created is in the center of our cylinder. Now we can create our hole. We just need a simple hole, 1.5 inches in diameter. We specify our point. We just need this to be in the center of the cylinder. So I'm going to approach the edge and just snap to the center. This should be a through body. And we'll hit OK. So we've got our cylinder extruded to 2 inches. We've got our 1.5 inch hole removed. Now we can look at these cutouts. Let's do this one here first. This one is looks to be a little bit simpler. So let's work on that one. Now that one is dimensioned in this side view here. So in the side view, we've got a 1/2 inch width and then a 1 inch length on it. The position of where it's located on the cylinder, we have this 1/2 inch reference dimension. We cannot drive geometry with reference dimensions. So we cannot put in this 1/2 inch to define where it is on the cylinder. But it says see note. So the note says both cutouts to be centered on the axis of the cylinder. So this cutout is going to be centered on this point right here. And that's why putting the origin at that center was important, because we can just reference that. We're actually going to use constraints to define where this cutout is located on the cylinder. But to actually make this cutout, what we're going to do is we are going to make a plane that is parallel to this axis right here. And then we're going to draw this rectangle, and then we can extrude so we can remove this material. So the first thing we need to do is we want to create a datum plane. There's lots of different ways to make datum planes. There's a ton of ways to position these and reference these. At a distance, all you do is select your object, and then you choose the distance away that plane is created. We have bisector. Bisector is a really common one. So let's say that we wanted to create a plane that was right in the center of this cylinder. Then we would do a bisector, and we would be asked to select the first plane and then the second plane, and it's going to create a plane between those two faces that we selected. This one's really common. We'll use that one a lot. And then we have a lot. The next one we have is tangent. Tangent is we get to select a curved surface, and the plane will be created tangent to that surface. I mean, this is always going to be connected. We can also choose an offset. We can also choose an angle in respect to whatever we select. But this is what we're going to use for our first cutout. So we're going to use tangent, and we just want to click on this surface. And it's going to create a plane that is parallel to this YZ plane right here. And that's what we want. Whenever we create a plane, you'll see these points or these dots on the edges. This is how we can resize the plane. But it is not defining the boundary of our sketch. So if we create a sketch that goes beyond this plane, that is okay. When we create a plane, the plane goes out to an infinite value. This plane never ends. Just because this purple area has a boundary does not mean that that's where the sketch boundary is at. So you can change this so that it's larger, smaller, whatever you want to do. But understand that that is not defining the size of the plane. It's just defining the size of the construction plane area that we see. So we are going to create a sketch. And we want to actually create the sketch on the plane that we just created. And I'm going to change the horizontal reference so that it is referencing the correct orientation. And then I'm going to specify the origin point to be the origin of our datum coordinate system. I'm going to hit OK. And now we're essentially in this view right here. So I'm going to make a rectangle that is 1/2 inch by 1 inch. When I made that rectangle, I didn't really care about the size. Remember, I'm going to just kind of put a rectangle out there, and then I'll dimension it and constrain it. I'm not going to worry about any of that while I make it. So now I'm going to come in and change these dimensions. This is 0.5. This is 1 inch. And now we still have 4 movable curves. So we've defined the length and the width of the rectangle, but we can still move these curves around. What we want is, just like the note says, we want the cutouts to be centered on the axis of the cylinder. So I want it to be essentially the origin point here to be in the center of the rectangle, or the rectangle to be oriented so that the origin of the cylinder is the same point as the origin of the rectangle, or the center of the rectangle. And we don't want to use that 1/2 inch from here to the rectangle, because that was reference geometry. We don't want to use reference geometry. What I'm going to use is what we've used before, the make midpoint aligned. Make sure that you have create persistent relations displayed or turned on. And we want to make midpoint aligned. And we want to select our motion curve or point. That's going to be this line. The stationary one is going to be, we're going to select the origin. We'll hit apply. And that's going to align the midpoint of this line with the origin point. So they're always going to be on the same axis right here. We're going to do the same thing for this side. Choose this line, the origin point. We'll hit OK. Now our sketch is fully defined. We've defined the position to be at the center of that origin. So now we can finish this sketch. And with it still selected, we can go to extrude. And we don't want it to be extruding out that way. We want it actually to be extruding into the material. And you can see our Boolean has changed. So before we were doing none. So if we did none, this would create a separate solid body. Now when we reverse this, it sees that we're going into the material, so it automatically changes to subtract. So it's inferring that we're subtracting. We could always change this if we wanted to. We could go to subtract. If we wanted to unite it, we could. This would combine the two solid bodies and make one solid body. But we do want to subtract this. But we are going to use a different end value. So we don't want to just use a value that's going to, go through this cylinder. We don't want to use 2 inches because 2 inches will go through. If we go to unite, you see that it's actually going all the way to over here. That's not what we want. We want it to go through this surface, through this material, and then stop after it protrudes into this inner diameter. We want to make it so that whatever dimension we give this inner diameter, it will always cut all the way through. It's not going to be a through hole, because if we do a through hole, it's going to go to this other side as well. And that's not what we want. We don't want it to go through the other side. We only want to go through the one side. So what we're going to do is go to until selected, and we are going to select our inside diameter. Now what's happened is it's going to go through, and it's going to stop whenever it hits this inner diameter right here. We can hit OK. And we have this section that's cut out correctly. All right, so now we need to make this cutout that's right here. This one's a little bit trickier because it's at this 30-degree angle. And then that 30 degree also defines the inside edge for the cutout. So there's lots of ways to get this 30-degree angle here. We can do exactly what we just did, or we did a tangent, and then just reference the plane here. We can say 30 degrees, and then draw our rectangle on that plane. But what we're going to do is we're actually going to go into the first sketch that we created, and then we're going to draw a line 30 degrees from this axis to give us that 30 degree, and then we can reference that line when we create our plane. So we're going to go back into our sketch 2. So I'm going to right click and go to edit with rollback. And we're going to create a line. We'll put it at the origin. If it's hard to snap to the edge, you can always go past the edge and then come up to trim and trim that excess off. And then we're just going to dimension this from this line to this vertical axis is going to be 30 degrees. The sketch is fully defined. Make sure that you're doing this in the right orientation. So that vertical axis for mine is that Y axis, because that's how I have this positioned. So that cutout is right here. That 30 degree is from this vertical axis. For me, this is the Y axis. Make sure that you have that angle correct. So now what we're going to do is I want to create a plane. I want it to be point and direction. And I want to select that point that we just made. It can be kind of hard to get it. It's kind of snapping to right there. So an easy way to actually be able to locate that is we go to view and we're actually going to go into static wireframe. Then we can see it. It's right there. We want to make sure that we are snapping to that point. So the endpoint. And now we have this sketch that, or this plane that is at that 30-degree angle. Now, if we needed to change that 30-degree, we could just go into that sketch and change that from 30-degree to whatever we needed to. We can hit OK. And I'm going to go back to our shaded with edges. Again, you can change the size of this plane if you want to. Go back to home and we are going to make a sketch on this plane. I'm going to do the same thing that we did before. So I'm going to change my horizontal axis. I'm going to flip that around. And then I want my origin point to be at the origin of our original datum CSys. Hit OK. And now let's go back and look at our drawing. So now we're drawing this rectangle here. So it is 0.25 inches in width. It is 1 inch wide or in length. And it's located half an inch from the center axis. Position-wise, we still have the note that says both cutouts to be centered on the axis of the cylinder. So we're still, just like how we used the constraints to position this, we're going to use the constraints to position this as well, except we do have this half inch that's defining how far away it is from that center. This is not a reference dimension, this is, so we cannot use this to drive geometry, but we will use this to drive it. So again, I'm just going to create a rectangle here. And then I'm going to dimension this. So this is 1 inch. And this is 0.25 inches. And so now we have 4 movable curves. So I can move this rectangle. So we are told that it is half an inch from the center axis of our cylinder, which is going to be this z-axis. So I can go ahead and put that in. I can select our z-axis and then the top part of our rectangle, and that's going to be half an inch. But now I can still move this left to right, and this is where that reference geometry comes in. So the reference geometry was half an inch, but our note tells us to center it on the cylinder. So come back up to our make midpoint aligned, and we want the midpoint of this line to be aligned with the origin. You hit OK. Now we have sketch is fully defined. We have no movable curves. We can finish this sketch. And now we can extrude this. And again, the vector is pointed in the wrong direction, so we're going to we're going to reverse our direction. And it's defaulted to 2 inches, but we don't want that. We actually want this to go all the way through. So we will do a through all. Our Boolean should be subtract, and we can hit OK. Now we can always come over here to our view. We can edit section. Want to just check to make sure that it matches the way that it should be looking on our section view that we have, and that looks about right. And before we're done with this, we had to create these planes. We have this line here that's going through the center to define that 30 degree. It looks a little bit messy. So there's a couple ways to get rid of to hide this geometry and this construction geometry. The way that we're going to do it is we're going to use layers. So while we're in the View tab, we have Layer Settings and Move to Layer. So Layer Settings, if we click on that, we only have one selectable layer right now. And that is the layer that has our datum CSYS. And you see as I check this box, it disappears and reappears. So we want to be able to put all of our geometry and construction geometry, the planes, datums on a layer or on different layers so that we can turn them on and off as needed. The way that we do that is we are going to click on Move to Layer. We are asked to select objects. You can come in here and select the individual sketches. There's a much quicker way to do that though. If we come up here to our selection filter, we can select whatever we want to select. So let's do the sketches first. So I'm going to select the sketches, and then I'm going to hit select all. Select all is going to select all of these sketches because that's what we have selected on our filter. And I'll hit OK. It's asking us to select the layer that we want to put the selected objects on. I want to put them on the sketches layer. And I'll hit apply. We want to select new objects. It's going to take us back to this window. And we can choose our datums, and we can hit select all. So that's going to choose our planes and our datum coordinate system. And we can hit OK. And we want to put that on the datums layer. And we can hit OK. Because we don't have any more items to put on a layer. Go back to layer settings, and we have another layer. That's the sketches layer. We had the datums layer. Now we have the sketches layer. So I don't want to see my sketches. So I'm going to uncheck that box, and I don't want to see these datums. And uncheck that box as well. Hit OK. And now all of those have been hidden. You can see them over here in your part navigator that they're kind of grayed out. It means they are hidden. They're still there. They're still driving geometry. They're still doing their thing, but we just can't see them. And it tidies up our model a lot, so we can way easier see, what's going on here. In fact, if we wanted to turn that edit section back on, I can see these cutouts more clearly. So make sure that you save this, submit it to the Dropbox on Canvas, and thanks for watching.